Okay, welcome back to the second video. In this video, instead of using the Pythagorean theorem to find the distance between A and B, I'm going to use the distance formula. And you're going to see that the distance formula is literally the exact same thing as the Pythagorean theorem, except the Pythagorean theorem looks a little nicer, and the distance formula has some more detail in it. So let me write down what that is, and then I'll show you how they're similar. So the distance formula, so D is going to stand for distance, is going to equal the square root, okay, of the quantity x sub 2 minus x sub 1 squared, this is all under the radical, plus the quantity y sub 2 minus y sub 1 squared. Okay, so let me show you how that all works. So what I want to do, since I have x sub 2, x sub 1, y sub 2, y sub 1, is I want to label my points as such. So the ordered pairs that I have here, I'm just going to quick label. So I'm going to label this as x sub 1, y sub 1, right? Just so we have some labels to put in our formula. And here I'm going to label x sub 2, y sub 2, okay? Now, once I have them labeled, I could literally follow the formula and substitute the points in. So the distance is going to be equal to the square root of x sub 2 is just 7, right? Minus x sub 1 is minus 5. So minus a minus 5. You're actually subtracting a negative 5. And we're going to square that, okay? Now, plus y sub 2. So that's 6 minus a minus 4. 6 minus a minus 4 quantity squared. Okay, so now this is really the same thing, right? Because if I think about it, right, let me just simplify what I have. 7 minus a minus 5, sorry, there should be other parentheses here. Hopefully that looks okay. 7 minus a minus 5 is really 7 plus 5. Well, 7 plus 5 is just 12. So what I'm doing is I'm taking 12 squared, okay? And didn't I get 12 squared over here, right? 12 squared is just the distance along the x-axis on the triangle squared, okay? So I basically counted that in the previous problem, but I also said you could subtract 7 and 5 and just realize that 7 and negative 5 are 12 units apart. So it's literally the same exact thing. It's just, you know, a more formal way of doing it. And then 6 minus a minus 4 is just positive 10. Positive 10 squared is the same thing I have here, right? Because the reason I got 10 is I realized that 6 and negative 4 are 10 units apart. So you're literally doing the same thing. It's just maybe more of a formal process. And then I have literally the same thing, right? If I take the square root, I know this is 144 plus 100. And I'm going to scroll up a little bit so you can see the distance is the square root of 244, which we already know can simplify to 2 root 61. So the distance formula is literally the same thing as the Pythagorean theorem. I would say there's advantages to both. Like personally, the Pythagorean theorem to me makes more intuitive sense. I think it's just easier to remember. And I like to use it. I like to draw triangles underneath the hypotenuse, if you will. So if you had 2 points and you graph them and you drew a triangle underneath, you could use the Pythagorean theorem quite easily. On the other hand, if you had like super big numbers, or maybe you had decimals, or just, you know, things that you didn't want to graph and maybe, you know, you didn't have enough space, knowing the distance formula and just the methodology for calculating the distance may come in handy. So it's a good idea to know both, but just realize that they give you the exact same result. Okay, so I hope that was helpful. And coming up next, we're going to do a scavenger hunt related to distance and midpoint.